Hello everyone, this is Prasanna Patil, working as Assistant Professor in the Department of CSE at MIT Mysore. Today we are going through the lab program number 1 of Machine Learning Laboratory 17CSL76. The first lab program is a finder's algorithm. Let's read the first lab program. Implement and demonstrate the finder's algorithm for finding the most specific hypothesis based on a given set of training data samples. Read the training data from a CSV file. So we need to concentrate on the algorithm first, that is find S algorithm, and using the find S algorithm, what we are doing, we are finding the most specific hypothesis. Okay, what is a hypothesis? Hypothesis is an assumption. It's a assumption, and we are predicting something, so that we are assuming something on the base of few data samples. And we are not only finding the hypothesis, we are finding the most specific hypothesis. Most specific means which is opposite of general, right? General hypothesis and specific hypothesis, both are opposite. Based on a given set of training data samples. So we have training data samples over here. A set of training data samples, so that we can make our hypothesis specific by reading the data samples one by one from the data set. And this data set is stored in a CSV file, so that's why read the training data from a .csv file. CSV stands for comma separated values. Okay, when you store the values by separating commas in a file, and if you rename the file with the extension with .csv, then that file will become CSV file. Simple. I'll explain how we deal with CSV file, how we access everything. So before going to the program, let's look into the algorithm. Okay, algorithm part. So this is algorithm. And the first step in the algorithm is initialize the hypothesis. We are initializing the hypothesis to most specific hypothesis. So before reading any data sample in the data set, we need to initialize the hypothesis to most specific hypothesis. What is the most specific hypothesis? It is null hypothesis. So depending on the number of attributes in the data set, we need to make those many number of null values in the hypothesis. So we'll understand how many values in the later part. Once we initialize the hypothesis, then we move to reading the data samples of the data set. So what kind of data samples we are reading here? We are reading only the positive training instances. So this is what the finders algorithms, one of the important feature of finders algorithm, that is, it reads only the positive training instance. Training instance is nothing but data sample from the of the data set. Okay, training instance or a record or a sample or data sample, all are same. So we are reading the positive training example here. That means we are not reading the negative training examples. We will be clear with which data sample is negative, which data sample is positive, and then once we read the positive data sample or a training instance, what we are doing, we are going through each and every attribute value of the data sample. Okay, for example, here if I consider this as the data set, this is the data set, and I need to consider now this as the concept in the sense actual set of attributes. This concept leads to this outcome in the sense the class, the label. Okay, so in the data set we have what we have concept and the target. Okay, concept is nothing but the attribute values. This is the first attribute, that is sky. This is the second attribute, that is air temperature. This is the third attribute, humidity. This is the fourth attribute, wind. This is the fifth attribute, water. This is the sixth attribute, forecast. Each and every attribute have their different attribute values. So all these are attribute values. Attribute values of sky, attribute values of air temperature, and respectively with the okay. And this is regarding the column, right? This is related to the column attribute. This is related to sky attribute. This is related to air temperature attribute, and humidity, and wind, and water, and forecast. So how many? 1 2 3 4 5 6 different attributes. And if you take the row wise, this is the first data sample. I just say DS data sample. First, this is second, third, and the fourth. Every data sample, each and every data sample has different attributes, and that data sample leads to a particular class, a particular target, a particular label, you can say. So what is the whole data set here? The whole data set here is it is regarding whether a person can enjoy a particular sport, yes or no. Yes or no, given these many attributes and their attribute values. Okay, this is what the data set we have. So here the first data sample is telling that it is a positive data sample, and the second data sample is again positive, and the third data sample is negative. This is a negative data sample, and the fourth one is positive again. So in this algorithm we are reading only the three data samples. We are not reading the third data sample because it is negative. So this is regarding the data set. We just come back to the algorithm. What we were discussing about. We were discussing about the for loop. This is the outer for loop. Outer for loop is to traverse through the data samples. Okay, this is the first data sample, second data sample, third, fourth, and the inner for loop is to traverse through the first attribute and the second attribute, the third attribute, fourth, fifth, and the sixth. Clear? So we have two for loops here, one for traversing through each and every data sample, and this, if the data sample is positive, then we are going through the attribute value, that particular data sample's attribute value, the first one, the second one, third one, fourth one, fifth one, sixth one. This is what the algorithm is. Then what exactly we are just here to find out the hypothesis, right? Our hypothesis was null hypothesis. Clear? Our hypothesis was null hypothesis, and we need to make it specific hypothesis. Null is the most specific hypothesis, but before reading any hypothesis, uh, correct? Okay, but after reading the first data sample, the second data sample, third data sample, the fourth data sample, the hypothesis keeps on changing. So how the hypothesis keeps on changing, and that too how we make the hypothesis specific. Okay, the algorithm is for each that is what the algorithm is. Now we'll just read this algorithm. We just come to this part by step how this algorithm works and all by with the help of diagram so that it will be easy to understand. We have already discussed about this, because what is it, we are making initial hypothesis. We just name it as H naught, and we have 1 2 3 4 5 6. Why do we have 6 null values in the hypothesis? Because we have 6 attributes, correct? We have 6 attributes, 1 2 3 4 5 6. That's why we have taken 6 null values. If we have 8 attributes, then we would have taken 8 null values. Okay, and this is the target value. We are not considering this while we are making a hypothesis. Okay, then we need to read the first data sample. This is the first data sample. I need to read it. So when I read the first data sample, according to the algorithm, if both are different, this is my data sample. Here it is. This is my data sample. And I am reading the first data sample, and this is my previous hypothesis, initial hypothesis. If both are different, then I need to discard this and I need to update the attribute value which is present in the data sample. So my new hypothesis is H1, my old hypothesis is H0. So now Sunny is my new hypothesis. Again same, both are different, discard. Both are different means this null value warm, this null value normal. Both are different, right? Then discard it. In the sense, whatever the value in the present data sample, that will be the specific hypothesis. Okay, this is after reading the first data sample. And why did we read this first data sample? Because its outcome is S. Next, going to the next. This is over. Okay, the second data sample, whose outcome is S again. Okay, whose outcome is S again. This was the hypothesis made after reading the first data sample, and now we are reading the second data sample. Now I need to compare this with this, because both are the same attribute. I cannot compare this with this, I cannot compare this with this, I cannot compare this with last one. I need to compare the first attribute value with the first attribute value. Sunny same. I don't make any changes from the previous hypothesis. I just keep it as it is. Warm with warm, I don't make any changes. I just keep it as it is. But here it is normal and here it is high. And you know what? This data sample leads to S, and this is the hypothesis. Which is made from the data sample whose outcome is S. Then how come a data sample with a normal value leads to S, and how come a data sample with a high value leads to S? It can happen, right? Yes, it can happen. A data sample with a high value can lead to S, and the same way another data sample with the normal value can lead to S. In that case, I cannot keep my hypothesis normal. I mean the value which was prior. Now what I need to do, I need to generalize the attribute value. I need to generalize the hypothesis of this particular attribute. Which particular attribute? Which attribute we are talking about? The third one. Third one is wind. I cannot keep the norm attribute value of attribute value normal for a wind attribute as same. So I need to make it general. So that's why I made it question mark. Clear? So this is third attribute, the fourth attribute same, fifth attribute same, and the sixth attribute same. Now this is the attribute, sorry, this is the hypothesis after reading the second data sample. Now we'll move to the third one. Third one is negative, so we just discard it because we are only reading the positive data sample. Okay, this is also over, reading over, but we have discarded it. That's why what I need to do, I am just updating the hypothesis as H3 but keeping everything similar. Okay, this is what after reading third data sample. Now we move to 1 2 3 is over. We are just reading the fourth data sample. Here is the fourth data sample. Sunny, warm, high, okay, strong, cool, change. Okay, this is okay. Since it is its outcome is yes, we are reading it, and this is the old, and this is the new. Both are same. Sunny, sunny, warm, warm, and question mark with high. What do I do? It's already made general. I cannot make it general further because question mark is the most general thing. Okay, so keep it as it is. Warm and cool, again here the conflict in the sense the mismatch. The hypothesis, this is the hypothesis made only reading by positive data samples, and this is also positive, that is yes. Then I cannot keep warm or cool in this hypothesis, so I need to make it general. In this case also and in this case also the outcome is S, and it's a general thing. Same, change, same, again both are different, then we make it general. So this is our final hypothesis. After reading all this, after reading all these data samples of a data set, right? Now we'll move to the program source code of the lab number 1. Okay, here we have we are importing CSV. This is the only module we are importing in the program. Okay, because we are asked to use a CSV file. Importing CSV, and how do I open a file like this? As you already know how to open a file, we need to use a method called as function called as open, and this is how we need to specify the file name. File name is enclosed within a single quote or double quote. Okay, and this is a file handler. This is a file handler which has all the information about this file lab1 data.csv, all the information including the content, what kind of data it has, where the file has been stored, everything. The file handler has all the information of the file. And how do I access only the content which has been stored inside the file with the help of a reader method. Reader method is stored within a CSV module. And how I'm using this file handler, I'm just using this file handler as an argument to the reader method, right? I'm using this reader method with the help of CSV module, CSV class dot reader, and using this file handler as an argument. And this will whole thing, this is the argument taken, this is the whole thing is taken as an argument to the list method, correct, list function. So what is it exactly? CSV.reader file, this will only fetch the content of all the the content of the file. And what we are doing here, we are converting whole content into the list. One second. That means the file handler has everything, and CSV dot reader, a file, this will be having everything. Means this is the first line, second line, third line, fourth line, fifth line. We can read this CSV dot reader file, whatever it returns, whatever the object file it is returning, we can read. If we want to read the data in this, from this object, returned object, line by line, then we need to use a for loop. Okay. Then we are converting it into the list. If we convert that into the list, then what happens? So this will be having, if I convert this into the list and if I store it in the data, so this is data of 0, this is data of 1, this is data of 2, this is data of 3, this is data of 4. Okay, so data is having now this information. Okay, and next is I need to find out the hypothesis length. So we already know there are 6 attributes, and I need to find out how many attributes are there. So how do I find out? I need to find out with the help of data of 0. So this is first, second, third, fourth, fifth, sixth, and I need not calculate how many data samples. I need to calculate how many attributes are there, because the number of attributes, the hypothesis has the number of null values that is equal to the number of attributes, different attributes. So that's why I need to take the length of data of 0, not length of data. Length of data is 1, 2, 3, 4, 5. If you take length of data, it will be wrong. So that's why I need to consider length of data of 0. Data of 0 is here. This is the first attribute, second, third, fourth. You can take data of 1 also, you can take data of 4 also, because everything has the same number of. And data of 0, that is the length. What is the length here? 1, 2, 3, 4, 5, 6, 7. But we have only 6 attributes. That's why I need to subtract it by 1. So now the length has the value 6. And how do I initialize the hypothesis? H is equal to 0, that is a string. This is a string with a 0, and everything is enclosed in a list. And this is multiplication into 6. This list value multiplied with number 6. That means we have a list with this null value copied 6 times. Next is this is just a printing of hypothesis what we have just initialized. And next is fine. Okay, we are just printing it, and okay, we just printed it. And next, data.pop. So why data.pop? Why data.pop? Because we need to deal with only the data samples. We need to discard data of 0. We need to discard the data of 0. data of 0, we don't need data of 0 because it is a heading of all the data samples. So that's why what I did, what we need to do, we need to pop it. Which one to pop? Pop the row which is present in at the 0th index. Okay, so data dot pop will modify the actual data in the object data, correct? So now the data is nothing but the data has become like this. See, this is what the data is. Now the data, this contains data of 0, data of 1, data of 2, data of 3. So this is now what exactly the data has. Next thing is to traverse through all the data samples because we have already initialized the hypothesis. So traversing takes traversing means there are two loops. One is the outer loop, and next one is the inner loop, right? That is the outward loop and this is the inner loop. And what is for the outer loop? Outer loop is to traverse through all the data samples, and once we traverse through the first data sample, I need to check whether that data sample is yes or no, correct? So that's why I'm including this condition. If the data sample is yes, then only I need to get into the second inner loop, that is to read all the attribute values. Otherwise I should not read the data sample, I need to skip it and I need to read the second data sample. Clear? So this is what the algorithm is. For I in range of length of data, this is length of data and this is length of data of I, because I am reading here the data samples and I am reading here the attributes. Data of I, what is I? I is the index, means data of 0. Data of 0 in the sense data of 0th row. Clear? And here data is two dimensional. Data is two dimensional. This is data of 0, this is 1, sorry, this is also 0, 1, 2, 3, 4, 5. From 0 to 5 there are 6 attributes. So data of 0, 0 is sunny. Data of 1, 3, data of 1, 3 is strong. Data of 3, 3 is strong. Data of 2, 6, sorry, not, there is no 6, it is out of bound error. Data of 2, 5 is change. Clear? Okay. So length of data of I is 1, 2, 3, 4, 5, 6, 7, and I am using -1 because I need to exclude the label. Now I am into the inner loop. I need to do? I need to check the first condition. What is the first condition? I need to check whether the sample, the hypothesis has any null value. H of j, H contains the hypothesis. J is initialized to 0, so H of 0 is null. If it is null, so when we are reading the first data sample, this condition gets true. So when we are reading the first data sample, this condition gets true and everything will be replaced with the data sample values. Clear? Just go through it. And this is the this condition will become true when we are reading from second data sample, means whenever the data sample is positive, okay, this condition will get true, because the value will not be null from the second data sample. What I meant was the value will not be null. Next is if H of j is not equal to data of ij, that means we are just comparing sunny with sunny. This is the, we are not comparing the data sample with data sample, we are comparing with hypothesis with the data sample. Since the first record has become the hypothesis, I am just comparing here itself. Okay, since the first data sample has become the hypothesis, okay, after reading the first data sample, the hypothesis is same as the first data sample because it is yes. That's why I am comparing here with here. I mean first data sample with the second data sample. We should not compare with the first data sample with the second. We should compare with the hypothesis value with the present data sample. Both are same. That's why both are same, right? It is actually not null, and we are into the second condition. Both are not same, then there is no question mark, correct? So that's why I have kept same. And see here, the first is, I'm reading the first. Sunny, warm, normal, strong, warm, same. Okay, so this is my hypothesis, and after reading, I just make it square bracket so that you can understand it as a list. Okay. And all are quoted with, these are all string. Okay, this is hypothesis. Sunny with sunny, no change. Warm with warm, no change. Normal with high, so I need to change, question mark. Strong with strong, no change. Warm with warm, no change. Same with same, no change. So this is what the hypothesis after reading the second data sample. Third data sample leads to no, so that's why everything will be similar. The fourth, next is after reading the third, we are reading the fourth data sample, that is sunny with sunny, warm with warm, high with question mark, strong with strong, cool with warm, question mark, change with same, question. So this is what our hypothesis. And this is the finders algorithm, and we are just printing it. Like H, and we are not traversing it using a for loop. No need to traverse through hypothesis using a for loop. We can just directly print it because it is a list object. This is regarding the finders algorithm. Okay, finders algorithm reads only the positive data samples, and this is what the disadvantage of finders algorithm, and that's why we move to the next algorithm, that is candidate elimination algorithm. But candidate elimination algorithm, the difference we'll discuss in the next lab program. What is the difference between finders and what is finders and candidate elimination algorithm? Thank you.